Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 8.1, Problem 1. This is Section 8.1, Problem number 1. It says, assume that you happen to know that the Watapa Reservoir has a total of 28,152 fish in it, with a weight that is normally distributed with a mean of 7.25 pounds and a standard deviation of 0.65 pounds. And just for fun, you catch 100 different random samples of fish. That'll take a really long time to do. Each of the 100 samples has 25 fish in it. It's a lot of fishing. So, part A, what do you expect the average of the 100 sample means to be? So from the given information, we know the average of all the fish is 7.25. But now that you've caught 100 samples, if you take an average of each of the means of each sample, what would it come out to? And it happens to come out to the same as the mean of the whole population. So if the population has a mean of 7.25, in this particular question, the average of the sample means will also be 7.25. So for part A, the answer is 7.25, same average. B, what do you expect the standard deviation of the 100 sample means to be? So again, standard deviation is a measure of how spread out your data is. So the standard deviation for the population in general is 0.65 pounds. That means on average, from one fish to the next, the difference in their weight is 0.65 pounds. But now for B, they're saying how spread out what's the standard deviation of the 100 sample mean. So from one sample mean to the next sample mean, how spread out are they? And it's not the same as the population. So the standard deviation of the sample means is sigma, the standard deviation of the population, over the square root of n, which is the size of the sample you're taking. And what happens is the bigger the sample is, you're dividing by a bigger number, and that spread in the data gets smaller and smaller, which is intuitive. It's what you would expect would happen. So for this particular problem, the sigma, the standard deviation of the entire population, is given to be 0.65. And the size of the sample is given to be 25. Each sample you took had 25 fish in it. So that's the value for n, how big the sample is. And 25 has a nice whole number square root. So the top will stay 0.65. Square root of 25 is 5, because 5 times 5 is 25. And if I divide 0.65 by 5, I know the answer comes out to 0.13. If you don't, just use your calculator and let your calculator figure it out for you. But you'll get 0.13. So you can see that the average from one sample to the next is not spread out, and it's not as spread out as one fish to the next. The samples are less spread out than the fish themselves, the sample means. So, part C, what is the probability that any one random fish will weigh less than 7 pounds? So if you just catch one fish, what's the probability that it's a little less than average? The average is 7.25. What's the probability just any one of them you happen to catch randomly will weigh less than 7? So for that, what we have to do, we can't look up a 7-pound fish in our standard normal chart. We're going to use the standard normal chart, and we get to use that because we happen to know that this is normally distributed. So we need to know the z value for a 7-pound fish. So z equals x minus the mean over the standard deviation. So x, the number we want to convert for, is 7. 7-pound fish, minus the mean. The mean of the population is 7.25. That's given. Over the standard deviation. So again, for the whole population, how spread out is it from one fish to the next is 0.65. So that's how it fills in. Do the math on top. You'll have 7 minus 7.25 is negative 0.25. And in the denominator, you'll have 0.65. So that's not something I can do easily in my head. So you would use your calculator. You would do negative 0.25 divided by 0.65. And my calculator will do that for me. And I get a result of negative 0.384615384. That's the z-value. That's what we need to look up. We need to look up negative 0.384615384. So to look something up in that z chart, the standard normal chart, step one is write the number to look up so that it has two places after the decimal. So the 0.384, 4 is the third place, it's not big enough to make it a negative 0.39. So step one, write the number to look up so that it has two places after the decimal. We write as negative 0.38. Step two, split the number into two parts by pulling off the rightmost digit. So that 8 will get pulled to the side. I'll have negative 0.3, and an 8 comes off to the side. Step three, put a 0.0 in front of the rightmost digit that you pulled off. So instead of 8, it's 0.08. So now, step four, what I will do is go to the negative 0.3 row of the chart, make sure you're on the correct page of the chart, the 0, 8 column, and see where they intersect. And they will intersect at 0.3520. So again, you'll be in the negative 0.3 row, the 0, 8 column. They will intersect at 0.3520. Now, is that our answer? Is this one of these cases where we have to do 1 minus the answer from the chart? The 3520 is the answer the way it is now because it says the probability that one fish will weigh less than. Less than questions, the answer from the chart is the final answer. So the answer for C is 0.3520. So there's about a 35% chance that if you catch any one fish, that one fish would weigh less than 30 pounds, about a 35% probability. Now for D, what is the probability that any random sample of 25 fish will have a mean or average value that is less than 7 pounds? So if you catch a whole group of fish and you find the average of that group of fish, what's the probability that the average comes out less than 7, not just one fish? So let me just make a little bit of room. Erase some of my work from part C. So again, this is going to use that standard normal chart. We need to know what value z is that we want to look up. And I can start with the same formula for z. X minus the mean over the standard deviation. But now when we're dealing with samples and not individual items, how you fill it in changes a little bit. So x, the number I want to convert for part D, that is still 7. That's what it says in the question, 7. So that's x. Minus the mean. So now technically it's not the mean of the population, but the mean of the sample means, which does happen to be the same. But we want the probability that an entire sample would have a mean less than 7 pounds. So I want to be clear that I want, even though it's the same number, the mean of the average of the samples. Now the standard deviation, how spread out is the sample means, that's the 0.13 number. It's not the standard deviation for the population. That's how spread out the fish are from one fish to the next. The 0.13 is how spread out the sample means are from one sample to the next. That's in the denominator. So now we can do the math. In the numerator, 7 minus 7.25 will be negative 0.25, and in the denominator, 0.13. And again, that's not something I can do easily without a calculator. The calculator does it so easily. So negative 0.25 divided by 0.13 equals negative 1.923076923. So that's a value I need to find in the chart. So again, there's a 4-step process to look up anything in the chart. Step 1, write the number to look up so that it has 2 places after the decimal. Right now we have too many places. So go 2 places after the decimal. The next one out is not big enough to make it a negative 1.93. It chops off at negative 1.92. So step 1, write the number so that it has 2 places after the decimal. There it is with 2 places after the decimal. Step 2, split the number into 2 parts by pulling off the rightmost digit. The rightmost digit is the 2, so I pull it off to the side. Step 3, put a 0.0 in front of the rightmost digit that you pulled off. So instead of 2, I write it as 0.02. And the final step is go to the chart. The digits from the left, in this case the negative 1.9, will tell you what row of the chart to look in. Again, make sure you pay attention to the fact that it's negative. So look in that negative 1.9 row, follow it out until you're under the 0,2 column. See where those intersect. Those intersect at 0.0274. Now again, because the question says less than, the answer from the chart is the final answer. If it said more than, we'd have to do 1 minus the chart number. But again, less than, I take the chart number just the way it is. So the answer to part D is 0.0274. It's about a 2 3/4% probability that if you catch a group of 25 fish, that the average of that sample would be less than 7 pounds. So you can see same numbers, but very different probability from when you're talking about just one fish compared to the average of several fish.